Okay, welcome to Thursday. So this is work period for expected value. This is typically a tough topic. So I thought I would go through a few examples. And maybe do what I've done in the past. Go through a few questions and then give you some work time. I don't know how many of you finished it. I asked you to start it yesterday. We had about half an hour left in class. So I think I'm kind of the same approach that I've done the last couple of times I've had work periods. I'm going to maybe do a couple at a time, like give you a few minutes. There are 11 questions in total. Since I started getting you to work on this yesterday, and I did give you about half an hour in class, I'm assuming that you got some things done. So let's take a look at maybe the first three, and then I'll give you some more time to work on the rest of the assignment. I'll chunk it up similar to what I would do in a regular class setting if I gave you a work class. So let's see what we have here. We have Julia hears that a lottery is selling tickets for $100 each, and that every ticket is a winner. How can the lottery make money if every ticket is a winner? Well, I suppose that they could give away a prize that was worth, I guess it would depend how many tickets are being sold. I suppose that they could give away prizes that were so small that they're almost worthless, correct? Like if you think about it, we could have a prize worth, I don't know, pennies, even though pennies don't really exist anymore. But if we only had a prize worth a few cents, then that would be some kind of a prize that was almost meaningless. It would certainly depend how many tickets they sold, right? Like if they sold many, many tickets. So each prize could be very small, right? Maybe a prize could even be just a little, I don't know, a little novelty item or a little, some sort of little sticker or you're certainly not going to win a lot of money if every prize is a winner. So there's little different gimmicks, right? You don't really know what the prizes are. Maybe the prize is a smile, right? It could be something silly like that. Let's try number 2. The probability of 3 coins all landing with the same side up, either all heads or all tails, is 1 in 4. Your friend wants to play a game where you toss 3 coins. If all 3 coins land with the same side up, you win $7. Your friend will charge you $2 to play. Calculate the expected value of this game. Okay, so expected value, we know that there is a formula associated with this, right? Expected value equals the probability of winning times the amount that you're going to win, take away the cost to play. All right, so that's the formula. So let's see again. The probability of all 3 heads or all 3 tails is 1 in 4. Your friend wants to play the game, and if you do, you win $7 and your friend. Okay, so all the info's there, right? We've got the probability of winning right here, because winning is 3 sides of the same coin. So my expected value is equal to the probability of all 3 heads or all 3 tails is 1 in 4. And how much do I win? $7. And how much is it to play? $2. Okay. So I punch that into my calculator. 1 in 4 means 1 divided by 4 times 7. Take away 2 and I get negative 25 cents. So I'm going to lose 25 cents. So this is not a good game to play. All right, let's try number 3, and then I'm going to stop and give you some work time. Lori owns a small business. She knows that if she advertises on the radio, she has a 40% chance of making $1,800. The radio ad costs $1,000. Determine expected value. Okay, I've got my formula here, so I'm going to follow it again. So what's the probability? In this case, a win is she gets that extra money, right? She gets that $1,800. Okay, that's regarded as a win in this business situation. So there's probability is 40%. So I know that as a fraction, as a probability number, that's 40 out of 100, right? That's the probability of winning. So 40 out of 100 times she gets $1,800, but the cost is $1,000. So she does not she can be expected not to make money. It looks like she's going to lose money. Because the expected value is negative, that's a loss. Do you think she should take out the ad? No. Because the expected value is negative, she will lose money. Is there a non-financial reason why she might want to put an ad on the radio? This would, I guess it would increase public awareness. Of her business. And so there's a potential this would increase business in the future. Even though it's a money loser right now, perhaps with the business she's in, there's a chance that it would increase business in the future. So I'm just going to put a little note here. Work on the next few questions for assignment 3. Okay, let's keep going. As I said, I know that if you're watching this later on in the day, there's going to be breaks, but I'm giving you work time. So hopefully, even if you're watching it later on, you can take those opportunities to work during your break. Let's try number 4. Rhonda finds a gambling machine that has an expected value of 20 cents. If she plays the machine 150 times, how much money can she be expected to, or sorry, a loss of 20 cents? How much money could she be expected to lose? Well, 20 cents might not be a lot of money, right? But if you keep playing that over and over, you're going to keep losing money. So that's a negative number, right? So if she does that 150 times, she can expect to lose $30. So over time, that's not so great, right? Let's take a look at number 5. The probability of drawing a face card. So if we just look at the picture here, I'm just going to put my face card here. Hopefully you can still see it. So the face cards are those cards in the deck of cards that have pictures on them. The Jack, Queen, or King from a deck of cards is 3 out of 13. Hal bets $5 on a game where he chooses one card from a deck of cards. If he draws a face card, he wins $25. Calculate the expected value. All right, let's see if I can. Sorry about this. I'm going to just fold this up so we can see the question too. All right. So number 5. The probability of drawing a face card is 3 out of 13, and that's how we win the game. So this is the probability of winning. Okay. Expected value equals the probability of winning is 3 out of 13. He wins $25 if he draws a face card. So that's the amount that he wins. And he has to, when it says bet, that's what he has to pay. So let's see what this works out to. So we get, okay, I get a big long answer, right? 0.769. So I would round that to 0.77. This is money. So I would interpret that to be 77 cents. The expected value of this game is 77 cents. That's positive, right? That's a good thing. If Hal plays the game 100 times, determine how much he can expect to win or lose. So I take the 77 cents and I multiply by 100. And that's going to give me, whoops, shouldn't have to do this. $77. That's not bad, right? All right. Are you guaranteed to make or lose the amount you calculated? No. This is still just an expected value. Not a guaranteed value. It's still just probability. It's still just an educated guess, I guess we'll say, because it comes with data as to what will happen. Okay? So keep working, please. On 5B, I got 76.96. Let's see. Cynthia, what did you use for? Cynthia, what did you use for part A? 5A. Oh, hang on. I got that too. Never mind. Okay, so 3 divided by 13 times 25. Oh, right. All right. If you went through, sorry, Cynthia, that would be acceptable. If you went through this whole thing again and used this and then times it by 100, you would get 76.96. I ended up just using my answer for part A to part B. So actually either answer is acceptable. So that's fine. I think because I used my rounded answer, I just used part B to get part C. Yeah. So actually your answer is probably better, to be honest, but I just used it. I just carried on. Okay. So keep working. I'm going to stop again. Keep working on assignment 3. I'll go over through every question. So we've got the next group I'll go through is 6, 7, 8, maybe 9. And I'll do that maybe in another 10 minutes. Okay, I don't know if I've given you enough time. I hope I have. I keep watching the clock and I don't want to run out of time. So we left off a few minutes ago at number 5. And let's take a look at the bottom of the page there, number 6 and 7. So let's see if I can fit. Let's see if I can fit number 6 at the bottom of the page. So we have Carlos bets $20 every week in a sports pool. His probability of winning is 0.17. If he wins, he collects $95. Well, this is just a standard question, right? Probability of winning is 0.17. He wins $95. He must pay $20. The word bet means he gives the person who's running the game the $20. That's his payment. Whoops. 0.17 times 95 minus 20. So he can be expected to actually lose $3.85. It's a negative number, so he's going to lose $3.85. That's quite a bit, right? Especially if he does it weekly, that's almost $4 a week. That's quite a lot. All right, I'll try number 7. A lottery has a winning prize of $1 million. Tickets cost $100 each, and a total of 40,000 tickets were sold, where only one of the tickets is the $1 million winner. Calculate the expected value for this lottery. All right, this is at least a slightly different one. They don't give us the probability of winning right away. We have to actually interpret that for ourselves. But if we look at this, let's see. The winning prize is $1 million, right? So that is... that's quite an amount of money to win, right? I'm just going to move this over here. So this is how much the winning person wins is $1 million. And this is the cost. Okay, so I have the amount one, the amount cost. I just have to figure out what the probability of winning is. And it says there's a total 40,000 tickets were sold. Only one is the winner. Well, the probability of winning then would be 1 out of 40,000, right? Only one of the 40,000 tickets is the winner. How much do they win? They win $1 million. And the cost is $100. All right, so 1 divided by 40,000 times $1 million. I'm going to do that again. 1 divided by 40,000 okay, so I get negative $75. So this game means this not game, but this lottery has an expected loss of $75 per ticket. Okay, what if you buy 20 tickets? That's not good, is it? So I have a negative $75 for each ticket, and I buy 20 tickets. That's going to be an expected value of, that's an expected loss of $1,500. That's a lot of money to lose, right? Okay, that was a little tougher, right? Because so far they've given us the expected value as the fraction or the percent number. This time we had to interpret that 1 out of 40,000 tickets. So again, I'm going to get you to keep working. I'm going to get you to work on the last page, and I think we'll have enough time to finish up these last few questions. And then I'll have so keep working on these. Okay. Okay, you don't really need to see number 8 right now, right? Because you'll be working on your own booklet. So Okay, since time is running out, I think I'll keep going and I'll just finish up the last few questions before class ends and I have to start my next one. So let's keep going with number 8. Hopefully you had time to look at this. So a football pool has 900 possible combinations of scores and there are 4 winners in each set of 900 tickets sold. Each winning ticket receives $200 and the tickets cost $5 each. Calculate the expected value. Okay, once again. Now this time there's not only one winning ticket, there's 4 winning tickets. So there's 4 chances out of 900. So 4 out of every 900 are winners. So that's my probability of winning, right? 4 out of 900. The amount that I win is $200 and the cost is $5. All right, so calculator. And we get a loss of $4.11, right? If you play this, or if you buy this particular football pool ticket, you can be expected to lose $4.11. How much profit is being made by the people running the pool? Let's see. Each winning ticket receives $200 and the tickets cost $5 each. Okay, well, let's see. There are 4 winning tickets, correct? So the amount collected, right? The amount of revenue, let's see, how much money did they collect? They sold 900 tickets and each ticket cost $5. All right, so how much money did they actually get overall? They collected $4,500. And the amount paid in prizes, right? Okay, what did they pay in prize? They had 4 winners and the payout was $200 each. That's $800. Okay, so the profit refers to the amount of money they get to keep after they pay their expenses, right? In this case, it is, I'll finish this up, Cynthia, and then I'll come right back to your question. In this case, they collected $4,500. They had to give back $800. So that leaves them with $3,700. Okay, so your question is, in 8A, since you're finding ones, shouldn't it be 1 out of 900? Yeah, no, since there are 4 winners, there's 4 chances to win. So it's the 4 out of 900. That's how we calculate it. There are 4 chances to win. There are 4 winners out of possible 900. It's just like I said, let's think of it this way. If you had 4 red marbles in a bucket of 900 marbles, the probability of getting a red marble is 4 out of 900. So there are 4 tickets with a W on it. W standing for win. Okay, let's take the number 9. The probability of winning against a dealer in blackjack is found to be 0.47. It costs $20 to play. Winning hand earns an average of 8. Okay, these are almost becoming repetitive now, right? So my probability of winning is 0.47. On the average, a winning hand will give you $40, but it costs $20 to play. And I get negative $1.20. Okay, so you're going to lose $1.20 every hand. So I can be expected to lose $90 if I sit down and play 75 hands. That's a lot of poker though, right? Let's try number 10. Number 10 is a big question, right? So number 10 is a lottery corporation offers a scratch ticket where the chance of winning is, move up a bit, right? The chance of winning is 9 out of 10. Okay, so the chance of winning is 9 out of 10. You have a 1 in chance of winning $20, 3 in chance of winning 10, and 5 in chance of winning 2, and the tickets cost 5. Determine expected value. Okay, for this expected value, I think we saw one on the previous page. There's more than one way to win. There are 1, 2, 3 ways to win. So I have 3 different ways to win. So I'm going to have those added up together. So let's see. My probability of winning $20 is 1 in 10. Okay, so that's the first way I can win. And there's also a 3 in 10 chance of winning $10. And a 5 in 10 chance of winning $2. Okay, so I can win this way or this way or this way. The cost is $5. So when I do all this, what do I get here? Let's see. 1 divide 10 times 20 and 3 divide 10 times 10 and 5 divide 10 times 2. Subtract 5, and after all that, my expected value is just $1, but it's positive, right? So positive $1. If you buy 15 tickets, what's the expected value? All right, well, 15 times $1, you can be expected to gain $15. What is the future of this lottery? Well, let's see. This lottery won't last long because they are giving more money than they are receiving. Okay. And then number 11, explain what it means if an event has an expected value of 0. EV of 0 is break even. They neither gain or lose money. A positive expected value, positive EV is the expectation of making money. So they would go ahead on their business transaction. A negative EV is the expected or the expectation of losing money. So if you had a business proposition and you end up with a negative expected value, it's something you probably shouldn't pursue. A negative expected value, when you calculate it, you probably shouldn't pursue it because you're going to lose money. So that's all the questions done for expected value. It ended up being quite repetitive. I think the only tricky part about expected value is you should know the definition. And also for expected value, know how to do a complex one where there's more than one way of winning. Make sure you know the difference there. Other than that, it's pretty straightforward. In a regular school year, you would definitely have to write this down on your formula sheet. because we don't have that given to you on your formula sheet. So that's it. I think that is it for today. So I will see you all tomorrow. Tomorrow, I guess we'll start. Please let me know at any time if you want extra work, if you think you want some extra worksheets or review. We've got one more topic to discover or to explore and discover in this unit, and it is the odds. There's two parts of odds, just regular odds and probability. So we will resume that tomorrow. So I'll talk to you tomorrow.